number 7, we have tangent squared theta times 1 plus cotangent squared theta. Couple different starting points. What did you guys do?
Number 1 plus cotangent squared.
Yep, cosecant squared. That's one of the Pythagorean identities, which remember those are on the formula sheet I will give you tomorrow. The ones you need to know are your reciprocals, and that tangent is sine over cosine and cotangent is cosine over sine. Pretty much everything else is on your formula sheet. So then if you don't know what else to do, we always go to sines and cosines. So tangent is sine over cosine, so tangent squared would be sine squared over cosine squared. Cosecant is the reciprocal of sine, so that would be 1 over sine squared theta. So then what happens? We have 1 over cosine squared theta, so that's the reciprocal of cosine, which is secant. So we check first if there's any obvious identity, which there's not here. So when in doubt, if you don't know what else to do, what do we always start with? Sines and cosines. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. If you want to add or subtract fractions, what do they mean? Denominator. So we have to take this one times cosine squared on top and bottom, and this one times sine squared on top and bottom. So then cosine squared times 1 is cosine squared theta over sine squared theta, cosine squared theta, plus sine squared theta over sine squared theta, cosine squared theta. All right. Once the denominators are the same, we can make one big fraction. What is cosine squared theta plus sine squared theta? Okay, so then what? Yeah, this is all one term. This would be the same as 1 over sine squared theta times 1 over cosine squared theta. And 1 over sine squared just means the reciprocal of sine, which is cosecant. 1 over cosine is the reciprocal of cosine, which is secant. So we get cosecant squared theta times secant squared theta. Are those okay? Moving on, question number 9, we asked about part D.
Can we also do 9B?
Yep.
Please?
Okay, so it's most beneficial to have these in degree form just because it's easier to think about whole numbers that add or subtract something rather than the fraction. So to change this into degrees, we multiply by 180 over pi. So the pi's drop. 180 divided by 12. Okay, so then we need two angles that add or subtract to 15. You could have also done 60 minus 45. If you did 60 minus 45, your final answer may have looked a little bit different than the one I gave, but it's equivalent. You would have had radical 3 minus 1 over radical 3 plus 1, if you did it that way, and it is equivalent. So then we know, if you haven't learned anything else this chapter, you have got to know that you cannot just distribute a trig function. We had like 3 sections talking about how that didn't work. Remember, I did an example the first time, and we did cosine of 30 plus 60 and cosine of 90. And we found out they were not the same if you just distributed. That's what all those sum and difference formulas are. Those are given on your formula sheet. So we are looking for the tangent of A minus B formula. So that formula is tangent of A minus tangent of B over 1 plus tangent of A tangent of B. So what is the tangent of 45 degrees? Yeah, it's radical 2 over radical 2, which is 1. Tangent of 30 is radical 1 over radical 3, so radical 3 over 3, over 1 plus tangent of 45 is 1, tangent of 30 is radical 3 over 3. So 1 times anything is itself, so we get to here. What I told you on these is that I would allow you to leave a radical in the denominator, but I didn't want a fraction in a fraction. So what's a quick way to get rid of that? So now if you distribute, 1 times 3 is 3, minus radical 3 over 3 times 3 is radical 3. The bottom 1 times 3 is 3. Radical 3 over 3 times 3 is radical 3. So 3 minus radical 3 over 3 plus radical 3. Is that okay? Let's look at B. So we have the cosine of negative 7 pi over 12. First, let's change that to degrees. So if you multiply by 180 over pi, negative 7 times 180 divided by 12 is what? Okay. You have several options from here. If you remember your negative identities, cosine of a negative is the same as cosine of the positive, so this would equal just the cosine of 105. If you didn't like dealing with the negative, you could also add 360 and get a coterminal. Or we could just evaluate it with a negative angle. So really 3 different paths to take. What did you guys do? Okay, that seems to be the most common method. So if you add 360 to that, what do we get? 255. So we need 2 things that add or subtract to 255 from our unit circle. On the test, if you need a blank unit circle, I will give you one, but you might need to refresh how to fill that out if you think that's going to be something you need. So if you want a blank one to practice on, you're welcome to have one. I have those copies, so just let me know. But what would we do here? Okay. And there are other options too. You could do like 135 plus 120. We can subtract things, so lots of different options. So now we have cosine of A plus B. So you go to your formula sheet. Cosine of A plus B is cosine of A. You guys tell me. You're all just sitting here watching me. Pull out your formula sheet. What's cosine of A plus B? Biggest problem I've noticed on these is just your positives and negatives. 225 is in what quadrant? Third. Reference angle, 225 minus 180 is 45. In the third quadrant, is cosine positive or negative? Negative. Cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Minus. In quadrant 3, sine is negative. Sine of 45, radical 2 over 2. Sine of 30, 1/2. So if you multiply these, negative times positive is negative, radical 2 times radical 3 is radical 6, 2 times 2 is 4. Minus negative would make plus, radical 2 times 1 is radical 2, 2 times 2 is 4. Different ways you could write that, you could put them together. You could write it as radical 2 minus radical 6. Any of those are fine, they're equivalent. Are we okay with that? Okay. Number 10, we didn't ask about, but that one's just a matter of using your cosine difference formula and evaluating it. So let's look at 11. Okay, so if I'm on the test and I'm looking at these, 7x, that's not even an actual angle I can evaluate. So I know I'm not going to get a single number answer. I'm looking at my formula sheet. I have a cosine squared minus a sine squared. Does that look like any of your formulas? We have a formula that says cosine 2a equals cosine squared a minus sine squared a. We have this side of it, so we have to give the other side. So that's the cosine of 2 times, what's my a? 7x. So 2 times 7x is 14x. And since it's not a number, we can't evaluate it, that's as far as we go. So just recognizing those formulas there. Number 12. And kind of answering questions with this, some of you have used different strategies even than I showed you in class, just using different combinations of your formulas, which is great. We are trying to find sine of regular x and cosine of regular x. So, I have to start here. I have cosine of 2x. So 2x, that tells me double angle. Look at your double angle formulas. If I want to find cosine of x, is there a formula that involves a cosine 2x and a cosine x? Yeah, we have one that says cosine of 2a is 2 cosine squared a minus 1. So, cosine of 2a, that's our cosine 2x, which we know is negative 3/4. So if I'm trying to solve this for x, or for cosine x, what would we do? Add our 1. Then we have to get rid of this 2, so if you divide by 2, that's 1/8. How do you get rid of a square? When you add a square root, we have to have positive and negative. To decide which one, we look up here. It tells me x is between 0 and 90. So what quadrant is that? In quadrant 1, we know everything is positive. So this is a positive. Square root of 1 is 1. How can I break down the square root of 8? 2. Square root of 4 is 2, radical 2. Okay, can we leave a radical on the bottom? No. So we multiply the radical 2 on top and bottom. So 1 times radical 2 is radical 2. 2 times radical 4, so that would be 2 times 2, which is 4. So that gives us our cosine x. There are multiple ways to get sine x at this point. we can draw a triangle. We can do it the same way we found cosine x using the formula. What did you guys do? Triangle. So the reason I couldn't draw a triangle from the beginning is because this was 2x, and what I was looking for was just a plain x. But now that I have cosine x, I could use that triangle to get sine x. We know we're in the first quadrant. Cosine is adjacent over hypotenuse. How would you get your third side? Okay, then you square root. We would do plus or minus, but we know since we're in the first quadrant it would be positive. We were throwing that. So that side is just the square root of 14. Here then, sine x, since this triangle is based off the angle x, we can just do SOHCAHTOA. Sine is opposite over hypotenuse. So radical 14 over 4. So these really just involve taking your formulas and solving for whatever we need. So you have to find a formula that involves what we need and what we were given, and plug in and solve. So let's look at 13. This time I told you cosine of x. Okay. So if I want cosine 2x, let's do that first. We have 3 formulas for cosine 2x. If you have cosine, which formula would you probably use? Not that you have to, but this would probably be the easiest. So we have 2. Cosine squared x just means you take the cosine of x and then square that answer. So radical 3 squared is 3. 5 squared is 25. So we get 6 over 25 minus 1, or negative 19 over 25. Sine 2x, there's only one formula option. It's 2 sine x cosine x. I don't know sine x, but I know that cosine x is radical 3/5. How will I find sine? Triangle. Cosine was positive and sine is positive, so we're just in the first quadrant. Cosine is adjacent over hypotenuse. So we do Pythagorean theorem. We get b squared equals 22. Then to get rid of a square, you square root. Because we're in the first quadrant, that's a positive. So that's radical 22. So sine, opposite over hypotenuse, is radical 22 over 5. When you multiply, you can only multiply things outside the radical together or things under a radical together. So we have this 2. Radical 22 times radical 3 would just be radical 66. 5 times 5 is 25. So that's my sine 2x. questions there. Looks like we didn't ask about anything else until problem 19. So we'll go ahead and work 19, 20, and 21 first, and then if we have more questions, we can go back and hit some of the ones we missed. So now when we get into the proofs, I really want to stress, guys, you have to write everything out. Because I don't know the difference when I'm grading your test of you doing it in your head and getting the answer, or you just knowing that's supposed to be the answer and you writing it down. Okay, so you have to show me every step of how you got there. If you're doing it in your head, you have to write down what you did in your head. So on problem 19, we always pick a side to box in. Not necessarily a right or a wrong here. And we know that if we get stuck, we could always turn around and work both sides and try to get them to the same point. So if you had to decide, which one would you box in? Right, well, it's really kind of a toss-up. One thing you notice about the left-hand side, it has both a theta and a 2 theta for your angles. So that might be a little more complicated just because the angles don't all match. So it might be easier to box in the right. Doesn't mean you're wrong if you did it the other way, it just might take a little bit more to get there. So the first thing we need to watch on these proofs, we need to make all the angles match. So if you have like a sine of theta plus 45, you need to use your difference formulas, sum and difference formulas to break those apart. If we have a 2 theta, we need to use our double angle formulas to break this apart.
Is the right side supposed to be 2 minus 2 though?
Oh, thank you. Wrote it down wrong. Okay. So if I start there, what is sine 2 theta equal to? If there's no other obvious formulas, we usually change things to sine and cosine. So I would change tangent to sine over cosine, and that's one you have to know. It's not on the formula sheet. Okay, this is like over 1. When you're multiplying, you can cancel anything that shows up on both the top and the bottom. What would that be? If I cancel that cosine, I have sine theta times 2 sine theta. So that would be 2 sine squared theta. Anyone see where to go from here? I've told you multiple times that the most important formula, the one we will use most often, is sine squared theta plus cosine squared theta equals 1. And there's a couple variations from that. If you solve for the sine, that means sine squared theta is 1 minus cosine squared theta. Or if you solve for the cosine, cosine squared theta is 1 minus sine squared theta. So if I'm looking at this, I have sine squared theta, but my goal involves a cosine. So I can replace sine squared theta with 1 minus cosine squared theta. And then how am I going to get to where I need to go? Distribute. So you get 2 minus 2 cosine squared theta. If you hadn't figured that out, you could have always went and worked the other side and seen if you could get it to the same point. So that's always an option. Are you okay with that one? Number 20. We have 2 cosine 2a over sine 2a. So I notice right now these are double angles equals cotangent A minus tangent A. And these are not. So I would probably box in the side with the regular angles because we have formulas for double angles. So 2 cosine of 2a. We need to plug in something for cosine 2a. Look at your goal. I'm trying to get both a cotangent and tangent. That means I'm going to need both sines and cosines. So which formula would we use for cotangent, or for cosine 2a?
Sine squared A minus sine squared A.
Okay. Not that you have to do it that way. If you used one of the other formulas, you could still get there. It's just a little more work. Sine 2a, we only have one formula. 2 sine A cosine A. What happens now?
The two's cancel.
Mm-hmm.
Then the losses pulled out.
Yeah. So you drop off those 2's. Now, if you look at our goal, we want 2 separate things. So that means I want to separate this fraction. If they're adding and subtracting, when you pull them apart, each piece is just over the denominator. So in the first one, what would happen?
The square and cosine cancel.
Cosine squared and a cosine, we can drop out one of the cosines. I'm left with a cosine over sine, which is minus sine squared A over sine A. We can drop off a sine. So I'm left with sine over cosine, which is tangent. So we get cotangent A minus tangent A. And that was what we needed. Good to know. So when I'm picking a side to box in, if there's one where we are going to be able to use identities, I would rather work with that one. You notice on the left we have cosine of A minus B, so that means I can use cosine difference formula. So I would rather work with that. So I'm going to box in the right. So cosine A minus B. Go to your formulas. What is that?
Sine is equal to sine B plus sine A.
So then, kind of like the last one, if I look at my goal, I want something plus something. I want 2 separate pieces. So to break this apart, you have to put each one over the denominator. This is one of those scenarios where if you just wrote down the final answer from here, that's not showing me enough work. I need you to write this stuff out so I know that you actually realized that, not that you just gave up and knew what the answer was supposed to be and wrote it down. Not that anybody would do that. What happens now?
Cosine will cancel.
Mm-hmm. Cosine over sine is cotangent B. Plus, in the second fraction, the sine b's drop, so you have sine A over cosine A, which is tangent. And that's what we need. Are there others that we have not worked and you want me to work? Which side would you want to box? If you want to add or subtract fractions, what do you need? Common denominator. So this one has 1 minus cosine. What does it need? This one has 1 plus cosine. It needs so in the first fraction, we have to distribute. So sine theta times 1 is sine theta plus sine theta times cosine theta over, if you FOIL in the denominator, you get 1 minus cosine squared theta. Okay, second fraction, sine theta cosine theta times 1 is still sine theta cosine theta. Sine theta cosine theta times cosine theta will be sine theta cosine squared theta. And if we FOIL the denominator, you get 1 minus cosine squared theta. We want to subtract these fractions, so what should I do? If we change this to a plus, we can distribute that negative. Then we have the same denominator, so we can add like terms. So we have a sine theta, cosine theta, and negative sine theta, cosine theta drop. And we have sine theta, cosine squared theta. Okay, look at our goal. We need things multiplied together, so that means we need to factor. What can you factor out of the top? If you factor that out, sine divided by sine would be 1 plus the cosine squared theta, which should look familiar. That's in the parentheses, what we're trying to prove, over what is 1 minus cosine squared theta? Sine squared theta. We can cancel a sine. 1 over sine would be the same as its reciprocal. Reciprocal of sine is cosine. And that's what we were trying to prove. So these are just some extra problems. If I gave you this, cosine 2 theta. So we have to look at our formulas. How many options do we have? 3 options. Look at what I asked you to find. I need the cosine 2 theta, but what I gave you was sine theta. So which formula do you want? Not the only way you can do it, but this will be the most direct way. So cosine 2 theta is 1 minus 2. Sine squared theta means sine of theta squared. And I told you sine of theta was negative 5 over 12. Do we need the fact that cosine is greater than 0? No, because the formula I chose, I don't have to find anything else, so I don't have to draw a triangle. So that just ended up being extra information. Okay, negative 5 over 12 squared, 25 over 144. And of course you guys are probably going to use a calculator, but I don't have one in my hand, so I'm going to work this out. So that would be 25 over 72. So 1 minus that would be 47 over 72. So sometimes choosing the right formula can save you some headache. Let's do another one. Let's say I said I'm asking you to find sine, and what I've given you is cosine 2x. So again, there's different options for how to do this. What would you suggest? So cosine 2a, that's my cosine 2x, that's 3/7 equals 1 minus 2 sine squared a. This time I'm solving for sine. So I have to subtract my 1, divide by 2, divide by negative 2, sorry. How do you get rid of a square? Square root. With that, we need plus or minus, so we have to figure out which one we would have here. If x is between 180 and 270, what quadrant is that? Is sine positive or negative in the third? Negative. This is square root of 2 over square root of 7. Get the radical off the bottom, so that's negative square root of 14 over 7. What else? Do we want another one along these lines? If you guys don't have any other questions, we can always do one more. Okay. This time I'm asking for sine 2x. There is only one formula choice here, so we can't just choose wisely and save ourselves time. We have to go with this route. We don't know the sine 2x. I don't know sine x, but I do know cosine x. How am I going to get my sine? Triangle. If x is between pi over 2 and pi, what quadrant is that? cosine is adjacent over hypotenuse. So then we can do our Pythagorean theorem. So to get b by itself, we do square root plus and minus, but which one would it be, positive or negative? Positive, because you're going up. So sine, opposite over hypotenuse, is radical 5 over 8. So 2 times radical 5 times negative 2 is negative 4 radical 5 over 9. Okay. What would I need to do on the left? Alright, so we have to do a formula for each. So cosine of x plus y. That is alright, plus cosine of x minus y. What would that turn into?
Plus sine.
What happens? So cosine x cosine y is 2 cosine x cosine y. That one might have been too easy. Let's do another. We've got a minute. Last one for today. If I said cosine 2x minus 1 over sine 2x equals negative tangent x. Which side would you box in? Right. Okay, cosine 2x. We have 3 options. We're trying to get tangent. Tangent is sine over cosine, so we need a sine on top. So which formula involves sine? Sine 2x, we only have one option. 2 sine x cosine x. What happens on the top? Well, the ones cancel, so we have negative 2 sine squared x over 2. Then what happens? 2's cancel and